Thanks for coming. It's the last session of a three-day conference, and I know it's pouring with rain on a dark November evening, so it's good to see at least a handful of you here making the effort. So the idea of this session is to talk about consolidation for SQL Server. And how many of you were at the virtualization session yesterday? Okay, a few. So my name's Justin Langford. I work for Coeo. We're a Microsoft Gold partner specializing in SQL Server. So we just do infrastructure consulting, remote DBA, monitoring and support for customers that outsource management of their SQL Server environments to us, basically. I spent just over 3 years working for Microsoft before I left to join Coeo. Hopefully you've all seen this already before now, probably too many times, but I contributed 4 chapters to this book actually. Christian Bolton, who also works for Coeo, was the lead author, so he came up with a kind of index page and the idea for the book. And the idea is to take notes from the field and our experiences of using tools to monitor and troubleshoot SQL Server and kind of try and distill some of that troubleshooting process with some of the less well publicized tools like RML utilities, SQL Nexus, read trace, those kind of things. Okay, so the framework is kind of similar to the virtualization presentation, where we'll look at the business and technical drivers around why would we consolidate, what types of consolidation can we undertake. We'll think about some of the planning and other considerations, particularly around SQL Server performance, requirements, and security, all those kind of hardware access problems that we might have. Discuss, and I've got some proposed guiding principles or a basis on which we would look to form a consolidation project and step through a framework for a consolidation project, and then look at potential issues and how we can mitigate some of those problems and solutions with consolidation. So the next 3 slides are going to be the same from the virtualization presentation, actually not yet, the ones after this. So consolidation, what's that? So the problem is that we've got lots of database servers running a single instance of SQL Server. Most of these servers are underutilized. Maybe they host one application only. We might have many bespoke deployments where application vendors come in, install SQL Server in a way that works best for their specific application. And this means that support is difficult and expensive to deliver because we have to learn about each application environment as we look at it. And licensing and maintenance, the costs are becoming harder to justify to have one database server per application. So consolidation can solve this problem by moving data into databases, by moving databases into instances, and by multi-homing instances on servers. So we're going to reduce the number of physical machines required for to operate the environment. The idea being that we're going to operate the same number of applications or databases with fewer servers and share these resources across all instances. We're going to get better resource utilization at lower cost. So I wanted to just give a very quick overview of today. We've got a server with a single instance of SQL Server. This is an example of SQL Server consolidation. We've got quite a few databases on that server. And across our estate, we're going to have a multiple of these situations. Single instances, some of which only host one database or application, and others with multiple databases. We can perform database consolidation, which means that we've taken the databases in this step from SQL 2 on server 2 and migrated those databases to run in SQL 1 on server 1. So we've effectively reduced the number of servers that we need to host this environment by one server, by 1/3 in this case. Further to that, we can perform SQL Server instance consolidation, which means that we run multiple instances on one physical machine. So in this situation, we've got SQL 1 and BizSQL both running on the same machine as named instances. So there's 2 different types of consolidation there: database consolidation and instance consolidation. For the purpose of completeness, I'll just mention virtualization because it's important that we differentiate between virtualization and consolidation and understand where we can combine these technologies and where they should remain separate. So in server consolidation, we've got a number of physical servers in the estate, and we can build one large machine running Windows Server 2008 and install a virtual machine manager or hypervisor layer there. And for an example of this is Microsoft's Hyper-V or VMware's ESX server. And within that virtual machine manager, we can define a virtual machine and go through a process called P2V, or physical to virtual, to create a virtual hard disk of a physical machine and transfer that into the virtualized environment, which means that we can effectively switch off the old machine from the rack. And we can do this across our estate to migrate those 4 physical machines to run on one piece of hardware. So it's subtly different, but there's quite a different process to go through, and there's some benefits and disadvantages to each of these which we should be aware of. So we're going to look at some similarities, and the guys that were at the virtualization will be familiar with this. So I kind of made this table of things which are the same between a virtualization project and consolidation, and things which are different. So both projects have a goal to reduce the total number of physical servers in the estate. Where both projects have the objective of saving power, licensing and maintenance costs, and both projects that we approach are going to have performance concerns. We're going to be worried that in the end situation, is performance going to be as good as it is when we're running physical machines? The areas that virtualization and consolidation differ are really around the number of Windows operating systems that we're running, because with a consolidated project we see that there are a fewer number of Windows, whereas with a virtualized environment we still have the same number of physical Windows machines running, they're just running in virtual machines. With consolidation we're going to have more databases per instance and fewer instances in the environment as we reduce those, whereas with virtualization we're almost lifting up the box and dropping it into the virtualized environment. Virtualization doesn't really give us much opportunity to upgrade Windows or SQL Server, but with consolidation it's a really good opportunity to consider doing that. And virtualization is really very much a black box approach where we point a tool at the physical server, it creates the VHDs, and then we drop those VHDs on our host. We don't need to know much about the way that the application connects to the database, the jobs or logins or integration services packages. We're pretty much agnostic to that, whereas with a consolidation project we really need a lot of effort to ensure that we document the connection strings, the security, SQL agent jobs, and we're really very familiar with that so that we can plan the migration quite accurately. Therefore there's a lot of testing and engineering effort involved in a consolidation project compared with a virtualization project. Virtualization offers an additional layer of technology with this virtualization layer, so we need to make sure that the organization has the right skills and experience to design and implement and maintain that. And it brings the benefit of having hardware abstraction, whereas with a consolidated environment we still have a close relationship between SQL, Windows and the physical server. So consolidation and virtualization work really well together, and when we're approaching a project to review an estate of SQL servers, we should be aware of the goals of a consolidation project, the goals of a virtualization project, and how we can map those onto the physical estate. So this slide really covers the dimensions of consolidation, and if we assume this kind of the spot in the middle is where we are now, we can approach this project from a number of angles in terms of reducing the number of databases, increasing the number of SQL Server databases per instance, and increase the number of instances per Windows host. And also we can consider increasing the number of Windows hosts per physical machine with virtualization. So some considerations for consolidation: resource requirements of databases, processor utilization, memory, disk I/O, network, tempDB. We've got a lot of dependencies outside of the individual user database, system databases, logins, instant-wide settings around security mode, max degree of parallelism, Anything that's SP configure is kind of falls into that group. Also some high availability or reporting features with replication and log shipping, database mirroring. We've got a maximum number of databases that can participate in mirroring per instance. So we need to be aware of that and familiar with the requirements of the application so that we can make sure we can support everything when it runs in a consolidated environment. And collation and sort order. So there's obviously a chance in a big environment that we've got disparate collations between servers. So a couple of slides on why bother with consolidation, what's so interesting about it and why is everyone talking about it. From a business perspective, the main motivation is to reduce cost. So we're going to reduce the cost to support the environment because we've got the benefit of standardization. We're going to enjoy better server utilization and lower space, electricity, cooling requirements and fewer licenses, hopefully. We're also going to benefit from better control with consistent operations, backup and restore, disaster recovery. Hopefully the idea is that we develop a standard model which we can apply that model to each of the servers that exist physically in our environment. And better business integration. So from a technical benefit perspective, we've got a couple of slides here. The first one looks at multi-instance servers. So this means that we install several instances of SQL Server on one physical machine, and this gives us the flexibility with multiple instances that we can do different things to each instance of SQL Server which is running on that box to control the characteristics and behavior from a performance perspective. We can do different things from backup recovery, the security model can be different. We can upgrade, so we can apply a service pack to one instance and not a second instance. So there's a few benefits. We can also have multiple development environments on a single server, and we can support larger and more diverse workloads with multiple instances when comparing that to a single instance. But there are some trade-offs or considerations because there is an overhead to deploying an instance. So we could deploy a single instance per server, and this avoids the overhead of running multiple sets of SQL Server, if you like. So each instance is going to have its own set of binaries. The DLLs and executables are going to be duplicated on the server once for each instance, and we're going to avoid that with a single instance. Some of the components are shared, and the automatic server settings are going to work better. So if we leave SQL Server to manage memory dynamically, SQL Server actually cooperates pretty well with Windows in terms of assigning more and releasing memory. So there's less admin work, but there are also some trade-offs or considerations which we'll look in more detail. So the final option is a multi-Windows instance. And really the alternatives here are to run Data Center Edition on a big Unisys machine, and we can have multiple physical window or multiple Windows partitions within that, or to look at virtualization as a solution. This means that we've got more autonomy, so we can restart an instance of Windows without affecting anything else which is running on that physical machine. And if we put too many of these these physical machines running on one computer, we're going to decrease the value, so we're going to lose the benefit of all the CPUs and memory that we have in the host. So this does in turn reduce the scale-up capability and increases the risk, since we have a single host operating system which manages these virtual machines or partitions. So the next phase is to look at high-level planning and what's kind of involved in a project. So we see the consolidation at the center of the spoke, and strategy, people, process, and technology being around the outside. And this presentation really just looks through a few of these. So from a strategy perspective, we need to know what the motivation for consolidation is and define the end goals. So what's the return on investment that we're expecting? How many physical machines are we starting with? And what's the goal for the end of the project with the number of servers? How are we going to measure and quantify those benefits? So this really means the financial implications. And we'll look at some guiding principles, and guiding principles are really some metrics or a basis around which we're going to approach the project. And I've got some suggestions for what they can be shortly. So with people, we've got a potential change in ownership of the data, and ongoing support and change management. Perhaps there are people in the business themselves who support and maintain or administer applications currently, and when they run on a consolidated server, it's not going to be ideal for them to have sysadmin access to the instance. So there might be some changes on that front. From a process perspective, we need to plan the operational performance monitoring, backup restore capacity, so that we can standardize these processes or have a model which we can apply to each of the types of consolidated solution. We're going to need to plan the process for migration and any rollbacks that we might need. From a technical perspective, which is the piece which most of us occupy ourselves with for most of the time when we're undertaking the project, but we should see this as one piece, is the CPU, memory management and storage performance, how we can achieve workload isolation, so how we can separate different databases, different instances running on the same physical machine to ensure that they don't interfere with each other or to minimize the risk. From a consolidation perspective, we need to be aware of name conflicts, so where we have database names at the same, object names, logins, the security model, bits and pieces like that, which really we need to know up front so that we can plan how to approach that. And having some management buy-in to this project is going to be critical. So if we take a roadmap, a project for consolidation, we'll assume that we're at the current environment in the bottom left-hand corner, the red circle. And normally in this situation, customers that are undertaking a consolidation project will be running SQL 2000, maybe 2005, and in some cases older versions, 6.5 and 7 versions of SQL Server. And their end goal is the top right-hand corner, the blue circle, where we're going to host a consolidated SQL Server 2008 environment. So the challenge here is, do we migrate them to an intermediate or staging area where we'll also perform an upgrade? So particularly if we're moving from older legacy 6.5 and 7, we can't upgrade them directly to 2008. So we might need to upgrade to an intermediate point at 2005 before reaching the end goal of SQL 2008. And then we can migrate them in a piecemeal fashion. Much more challenging is to take the current environment and migrate directly to SQL 2008. And indeed, if we're running versions older than SQL 2000, it's not going to be possible to go direct in that sense. So we talked about some guiding principles, and these are really important to kind of envision and agree when we're approaching the consolidation project. So there's some examples here, and I'm just going to walk through these, and these are things which you can evaluate, customize to your environment, adopt, and kind of really agree with management around this is how we're going to proceed with the consolidation project. So the first one is that we'll consolidate only non-critical workload initially. So we're going to build some confidence in the process, in the stability of the environment and hardware. We're going to convert applications or databases to SQL 2008 before consolidating. So this means that we're reducing the risk by separating the upgrade from the consolidation piece. The more things that we're changing at one time, the more the risk increases. And the more that we can do to isolate a change, if there is a problem, the better chance we've got of fixing it. We're not going to consolidate OLTP and decision support workload onto the same Windows host. So we're going to say homogeneous in terms of the types of workloads that we'll combine. We're going to combine workloads of similar characteristics into multi-database SQL Server instances. So we'll have a small number of instances which run databases which are of the same type. And we're not going to consolidate databases into fewer databases. So we're going to keep the database boundaries the same as we go through the consolidation. We'll use additional instances when dictated by characteristics, capacity or use characteristics. And we can use multiple SQL Server instances to keep dissimilar workloads isolated. So this means that we'll achieve some isolation at the SQL instance level by separating those into separate instances. One important one in terms of managing the scope of the project is really to avoid enhancing application or database functionality during consolidation. So we're going to resist the temptation to do anything to fix problems that we see, because the scope can easily widen and we end up overrunning on a project and not meeting the objectives for the consolidation. We can use multiple instances to isolate workloads with naming conflicts. If we've got logins that conflict, that have the same name on two servers, we want to put them onto a single server, we either have the option of renaming the login and changing the way that the application interacts with the database, or we can put them into separate instances. And one of the nice ways to approach this type of project is to look for situations where things can't work together to begin with, because if we've got two physical machines with two applications or two databases hosted on them, and we know that they can't work together, that gives us some parameters to work with when we're trying to combine those. We're going to strive to maintain transparency in user experience. So this means that there is no impact or no problems affecting user experience while we're doing the consolidation project. And we're going to drive standardization in operational and support practices. So we're going to simplify the environment so that it's easier to support and there are fewer exceptions to the model for the SQL Server estate. Does anyone have any questions? Does that kind of make sense? It's relevant? Okay, so we'll look at the planning, design, and implementation. So this goes through 4 stages of a consolidation project, and we'll look at each of those in a bit more detail around what we can do at each of these steps. So the first step is, or the first stage is envision, and the first step is an assessment of the current environment. So we're going to look at the network topology, the data centers, what resources we've got in terms of making an inventory of servers, processors, memory, disks, network, the requirements in terms of applications and service level agreements, requirements for disaster recovery and RPO and RTO, the recovery point objective and recovery time objective of each of these applications. So we can start grouping these applications into groups or areas of like requirements or similar requirements. We'll look at the workload profile, so we're going to take a baseline looking at the CPU, memory and disk activity on each instance in the environment. And we're going to look at features that are used within SQL Server for each application so that we can identify where we can use the minimum license possible and still support all of those applications. So if we have a number of different standards, then we will group the applications onto the instance with only the features that it requires. We're also going to document linked servers, extended stored procedures, and user stored procedures in master. And there's actually a tool which I've got a link a bit later on called the Microsoft Assessment and Planning Toolkit. And we can run this against an environment, and basically it makes an inventory of everything that's running in the environment. And I've got an example here where we've got an inventory of database servers, integration, analysis services, and reporting services. So we've got a summary of everything that's running in the environment at the moment. And this breaks down into more detail where we can see the SQL Server build number, service pack edition, whether it's clustered or not, what language is installed, what directory SQL Server is installed to, the service state, startup mode, the host. So there's a whole load of information, processors, cores, CPU, disk space, and this basically is generated by the tool which will go out and discover all of the SQL servers that are running in the environment currently and build this summary which gives us an overview, inventory of the estate. So once we've done that, once we've got this inventory, it's a really good idea to look at the applications. So we then make a list of applications and make a matrix to say, these are all the databases that we've got, these are all the applications that we've got, and these are the databases which are used by each application. Once we've got that mapping, we can start trying to find vendor management relationships within the organization to try and work out who supports which build of SQL Server and make sure that we've got buy-in from the business units as we're progressing. The second step within Envision is to identify the target market and develop the consolidation principles. And this is really our first cut of the to-be environment, so a picture of what the end goal is going to look like. We can get some feedback on this, review the target environment, review the financial justification to work out whether we're going to meet the objectives of the project in terms of return on investment. And we can review these guiding principles to adopt some of those or customize those based on the goals of the project and the organization culture as well. The second stage is around planning and designing. So this is to design in more detail the future consolidated infrastructure. And this is based on the guiding principles. And we're going to document operational performance monitoring, backup recovery. We're going to build this model which is going to meet the needs of each of these applications from every perspective, from a technical point of view, and review this design. Still within stage 2, we'll do some migration planning. So this is so we now know what the end goal is, what the to-be environment is going to be like, and we know what our existing environment is like. So the next step is to look at the actual migration planning and what method we're going to use to move these databases from their existing location to the new consolidated environment. Maybe we want to use detach and reattach, backup, restore. For very large databases, we can use manual log shipping to minimize the downtime between migrations, and really look at whether we need some intermediate staging environment if we're upgrading from older versions, if there are any sequences or dependencies between applications and databases, and work out the scripts that we're going to use, and make sure that we're monitoring the scope creep, so make sure that the remit and the scope of the project remains quite focused. So to implement this, we're going to commission the consolidated environment for test. So this means that we build the new consolidated environment, but we don't use it for production yet. We're just going to dry run and test the migration process and test the applications, pointing a test application against that new consolidated environment without actually switching the live environment. This means that we can build confidence in the process, build confidence in the stability and robustness of the new consolidated environment before we've actually got any live workload there. Stage 4 is deploy and stabilize. So this is really where we're doing the deployment onto live. You know, we've done the testing. We're pretty confident that the workloads will cooperate together, and now we're actually going to do the live deployment. This is going to be ideally transparent user experience, so nobody's going to know they're going to go home one day and come in the next day and their database is migrated, but there's no effect to the application in that sense. And we're going to measure the new service and compare it with the old environment. So this is where the baseline comes into play. And people are very quick, developers particularly, to point at the infrastructure and the database platform as being the cause of performance problems. And we need to be able to categorically prove your reads per second and writes per second to the storage were this on the old server, and this is what they are on the new server. So they're the same or better between before and after the upgrade, the CPU utilization, TempDB consumption, really to get good visibility of those components so that we can be sure that we de-risk the project for ourselves to be able to prove the performance characteristics before and after the consolidation. Okay, so some technical considerations, and this is arguably the most interesting component. So with multi-instance servers, we'll take a situation, this is just the diagram lifted from the first slide, where we've got server 1 which runs 2 instances of SQL Server on it. What can we do to isolate those instances to stop them interfering with each other? So if a crazy query happens on one server, how can we stop it affecting databases which are running from the other server? Has anyone got any ideas or suggestions on what we can do?
You can sort of just have one instance running on 2 CPUs, say, and you can configure its memory so there's enough memory for the other instance,
yep.
etc.
Okay, so we can use min-and-max server memory and an affinity mask to bind the instances to specific CPUs. That's pretty good. So min-and-max server memory, CPU affinity mask, first two in the list. We can also use Windows Server Resource Manager. So that can be pretty useful in terms of setting max and min thresholds for CPU and for memory of the instances. If we were running with a failover cluster, we can also control the possible owners and preferred owners of each service or application group, and that controls, if we have say a 4-node cluster and we might have 6 or 8 instances of SQL Server, if we're running in an n+1, so we have one server which is redundant, we can control which physical server the instance fails over onto with the possible owners and preferred owners, which can be quite useful. And we also have a setting called anti-affinity class name, and this means that we can prevent 2 instances of SQL Server running on the same physical host in a situation of failover, which can be quite nice if we've got a couple of very high demanding, very performance demanding instances and some others which are less important. We can prevent those 2 from running side by side on the same machine and force them to be separate in a failover situation. So for multi-databases, so in this situation, we've got a single instance on a single server, and we've got a number of databases running on that server. Anyone got any suggestions around how we can mitigate the risk of those databases interfering with each other? Yep. Perfect. So Resource Governor is the technology in SQL 2008, which means that we can set some parameters around workload. So we can classify incoming connections based on the login, and we can set parameters which mean that we can guarantee a certain proportion of the CPU and memory that's allocated to that instance to a group of users. So we can really prioritize how those resources are divided among the users of the server. However, there are still some things which are unmanaged, like the number of worker threads in the instance, which is fixed at startup time, and that isn't going to be equally divided between the applications running. They're pretty much grabbed as they're connected. TempDB as well, we don't have any method to ring fence areas of TempDB for different applications, so there's a risk that something which goes wrong with a query or an infinite loop that's running with temp tables can exhaust TempDB and affect all of the applications which are hosted on that server. And the final one is plan cache, because there's one plan cache per instance, and we don't have any way to stop one of those applications causing a problem with plan cache. So just a couple of things to have in mind that we can protect and can isolate, and some things which we can't isolate. Has anyone got any questions? Does that make sense? Great.
So are we saying from that multiple databases on one server isn't a good idea? If you want to do that, you want to do different instances so that you can control them better.
Yeah, so the question was, is it a bad idea to put multiple databases on the same instance? And I guess that there's a trade-off, and this is the whole challenge with the consolidation project, is finding the right balance, because there's quite an overhead with we don't want to have one database per instance, because that's going to be wasteful and very resource intensive. And at the same time, we don't want to put 2 mission critical applications on the same instance where we can't control certain aspects of SQL Server resources. So I guess it also depends on how well behaved the developers are and the change control and testing process, because we can mitigate against problems with these areas with good testing and thorough testing. So if we have a stable application where there's a very rigorous change control and release cycle, then we can be pretty confident that the risk is low. If the developers are developing on production and got their fingers in the pies all day, every day, then we've got a volatile application, and that's a really bad idea to put in a shared instance.
So it's not, yeah.
Yeah? Great. So just a slide on resource governance for anyone that's not familiar with this. So there are entire sessions and days training that you can attend to do with resource governance, and I've got one slide on it. So this is very much an introduction to, or an overview just to let you know what it is. So basically this means that we can develop certain profiles for different users and allocate resources to that profile. This means that we can limit the impact of a bad query on the rest of the server. So we can really try and ring fence some of the users. And the idea here is that the guys from the marketing department that run a report to generate all of the sales that have been made in the last 12 months, we don't want them to be able to block out all of the other users from the system while their huge report is generated. So we can lock them down with a ceiling of memory and CPU, which means that we're going to kind of cap the impact that they can have on all the other users. And we can group them based on their logins. So if the application's using a specific login, we can profile that connection. Is anyone using Resource Governor in production? Okay. So there's a slide kind of on each of the main resources now, and what we can do to influence and affect those. So with Processor, we've got the user mode scheduler in SQL Server, and there's one scheduler per logical CPU. So if we've got a multi-core box, we have one scheduler per processor as it's presented to SQL Server. And when a connection is made into SQL Server, it's assigned to a scheduler, and that scheduler can move around based on the actual CPU that's being executed at the time. All batches and commands from that connection are executed by the assigned scheduler. But we've got some caveats around the affinity mask. So we can configure this SP-configure setting for CPU affinity, and that allows us in a multi-instance machine to bind one instance to 4 CPUs or 2 CPUs, and another instance to CPUs 4, 5, and 6, so that we can isolate those two. However, there's one of the drawbacks of this is that the scheduler will stick to a processor when we enable an affinity mask. So if we grant an instance access to 4 CPUs, every connection that's made is bound to the processor which it's assigned in the first instance. And what this means is that we can create a situation where we have hot CPUs. So we have one CPU which is very busy while other CPUs are idle, and if we weren't using an affinity mask, these connections would be round-robined among the CPUs and the server, so the load would be much more evenly balanced. So it can actually be a bad thing to set the CPU affinity for that reason. In terms of memory, we've got a need for virtual memory for the procedure cache and plan cache, based on the size of the databases, procedures, and stored procedures. Using multiple instances means that we've got more control of the memory between instances, so we can ensure that we don't experience memory pressure so readily. We've got an option to statically or dynamically configure memory within SQL Server. So by default, the memory is dynamic, and we can tune it based on our requirements to divide the available user mode memory among all of the instances which are running on the server. And in this situation, we can ensure predictable performance, but it's not necessarily the best performance, because we can have, again, one instance which is very memory bound and another instance which isn't really using its memory, and we're not able to be flexible with those once we set the min and max server memory. But it does provide predictable performance, which is more important to most people. In a failover cluster, it's important that we calculate the requirements of all of the instances, and we're clear on the number of physical machines we're planning to fail. So in an N+1 situation, we're planning to operate with 3 physical machines. So we can survive the failure of one of the nodes, and the remaining instances should be able to operate within the physical memory on all of the servers that remain. And we need to consider the situation where we have simultaneous multiple failovers. So what happens if more than one server fails in this situation? Are there instances that we would prefer to keep online while we take others offline to to provide the core business services. In terms of storage, as always, storage performance and configuration is critical for SQL Server, and doing proper planning and testing to make sure that we've got that we're squeezing the most out of the storage is going to have great payback. So it's going to be really worthwhile to do that up front and make sure that we've got the best configuration. The normal I/O performance guidelines apply, so we should forecast the growth for data and logs. Consider using dedicated disks for large or high growth databases, so even if we've got an instance with multiple databases, we can isolate a large or high throughput database onto separate volumes so that they receive some benefits there from the storage. Some considerations: more spindles is less contention. We should always separate our database log files to reduce contention. We should typically use a dedicated disk or LUN for TempDB so that we're separating TempDB from our user databases. The HBA queue depth, the HBA is the host bus adapter, basically the network card for the SAN, and this has one of the parameters in the drivers for this is the queue depth. And we can increase the throughput to the storage by increasing the queue depth on the HBA, and that's definitely something that's worth testing. Disk sector alignment is something else. Is anyone familiar with disk sector alignment? Okay, good, well done. Sorry? Disk part, yeah. So what this means, it's not a problem in Windows Server 2008, but in 2003 and before, there's a partition offset at the beginning of every volume, which is 63K, and the block size that's written by SQL Server is 64K. And this means that every I/O effectively straddles two blocks on the disk as it's presented. So we can format the partition with a greater offset, and that means that every block has a one-to-one mapping between the read or write that SQL Server is making and the one that the storage is making underlying. So we don't force them to be, when they're straddled, to make a 64K read or write requires two blocks from the storage. So we can get really great performance improvements by performing disk sector alignment. It's not a problem in Server 2008 or Vista because it uses a 1024K, a 1 megabyte offset, so it's a happy number in terms of computing, and the offset is correct then for every subsequent block read and write. Okay, other considerations to kind of document when we're approaching the consolidation: linked servers, SQL agent jobs. It's really a chance to kind of tidy up and rationalize some of these things to make sure that we've got the minimum necessary. Integration services packages. We should consider things that are stored in the system databases, so master model and MSDB. Any name conflicts we mentioned already here. We need to make a plan for whether we're going to separate name conflicts across different instances to avoid clashes, or whether we're going to bite the bullet and rename something. Any modifications to system tables, which there shouldn't be, or startup procedures. And any explicit references to server names or paths that we might need to change. From a security perspective, this is kind of one of the big considerations when we're performing consolidation. Any conflicts between the current model and the to-be server environment, login names, functions, SIDs, anything that could be auto-generated and overlapping between the servers. We need to make sure that we're very clear about what's being used and how we can minimize the risk of this happening. Rights for a SQL agent service account and XP command shell. What are we going to do with that? How are we going to handle those situations? And users with administrative privileges. So previously there might be super users or power users in the business that have a high level of access to a database server. And how do we want to proceed with that and reduce the risk once they're running on a shared environment? And if we can migrate to domain accounts, then that's a really good way to improve security at the same time as consolidating. Collation and sort order sequences. Again, there's a whole area of SQL here with making conversions and how we can support this, and whether we need to know whether there are any differences and whether we should tackle these. What's our plan going to be? In terms of limitations, there are some limitations which differ between Standard Edition and Enterprise Edition. I've just pulled out some of the summary here. So the maximum number of CPUs that's supported in a standard edition of SQL Server of SQL Server 2008 is 4. And Enterprise Edition supports the maximum that the operating system edition that we're running on supports. From a virtualization perspective, with Standard Edition, we license per CPU. With Enterprise Edition, there's an unlimited support. So if we license the sockets of the host machine, we can install multiple instances on there for the cost of just the Enterprise license. So it's quite an attractive opportunity to move to Enterprise, and then we can run as many instances on there as we want. So that leads us quite nicely on to the next one, which is what's the maximum number of instances. So does anyone know the maximum number of instances per server? How many? Any other takers? 16? Yep, so it's 16 on Standard Edition and 50 on Enterprise. I've actually got a couple of books to give away, and you can take one of these books at the end. So I contributed a chapter to each of these books. They're exam guides on server performance tuning. One's for database implementation and maintenance, and another one for database design. So I wrote one chapter in each of those. And the maximum number of databases. So for the second book, does anyone know the maximum number of databases per instance? 256? Anyone else? 255? Higher? Higher? 1024? Christian says 32,000, but he wrote the book as one of the chapters in the book as well, so he doesn't get one. You get one of your own books. Congratulations. Yeah, so it's 32,000. Goodness knows why you would want to do that. I think it's a really bad idea, but that's the theoretical maximum. So we're coming to the end. Just a couple of links that might be useful. So I mentioned MAPS, the assessment and planning toolkit, which will do the inventory of your existing estate and give you quite an overview of that. Windows System Resource Manager, which has been around since Server 2003, but this allows us to partition instances on a CPU basis without using the affinity mask. So we can have 4 instances of SQL Server and limit the percent CPU that each instance will take without having to bind them to the physical CPUs. I've never used it. So I've spoken to customers about using it, but I haven't had anyone that's actually needed it actually. So yeah, I've experimented with it on a test environment and it does work. So I'm quite intrigued to use it in production, but we've never had a situation where we've needed to, basically. Okay, so in summary, we can hopefully now you've got a good idea of how to plan, design, and deliver a consolidation project with the approach that we can take for kind of documenting the current environment, making some kind of model of the to-be environment for consolidation, and identify good candidates for consolidation in terms of applications which will coexist well together, and a good understanding of an approach to consolidating an entire estate.